It is necessary that the point of the reverse curve must be 1/4 the distance from BC uh, from point B. So find the radius of the first curve. Find the length of the road from point A to D. We use arc basis. Find the cost of concrete pavement from point A to point D. So, given yung mga lines o siya yung mga traverse line nung roadway. So, it means that point A and B, point B to C, point C to D. So, siya yung mga siya yung traverse natin. So, yung point kung saan nag-intersect yung dalawang line, yun din yung mga points of intersection nitong reverse curve na mapo-form natin. So, paano to isa-solve? First, draw the figure with the given azimuths. So, ganito ang figure niya. Line AB is due east. This one. Point A to point B. So, point A doesn't necessarily mean that point A is the PC. So, pwedeng hindi yan. Kasi nga, traverse line pa lang siya. Point B to C. So, since point B and C, siya yung dalawang point of intersection ng dalawang ng reverse curve. So, itong line na to, ito yung common tangent of the reverse curve. Point C to D. Okay. So, point B to C pala, the azimuth, 242 degrees. So, measured from south, clockwise, 242 degrees. So, from due east, which is kung i-extend natin yung line na yun, when we measure the angle from the south going to east, di ba ang total niyan ay 270 degrees. When we subtract 242 degrees, ang matitirang angle ay ito. Itong angle na to. Which is the angle of intersection of the first curve. So when we subtract that, that is equivalent to 28 degrees. So, kung i-continue natin itong line BC with an azimuth of 242 degrees, line CD naman ay may azimuth na 302 degrees. Recon from south. So, itong angle na yan, pag sinukat mo, 302 degrees. To find the angle of intersection of the second curve, so just subtract the two azimuths of the succeeding lines. So we have 302 and 242. Just subtract that. Ito ngayon yung equivalent natin na angle of intersection, which is 60 degrees. Okay? So given yung mga length nung lines, A to B is 185. This is 185 meters. Tapos BC is 122.4 from here to there. 122.4. And we have 285 to from point C to D. It's 285 meters. Okay. So, sabi dun sa problem, it is necessary that the PRC or the point of reverse curve must be 1/4 the distance from point B. So, 1/4 daw nung distance nitong B to C ay yun yung location ng PRC galing sa B. So, dun pa lang, ma-identify na natin agad yung separate tangents of the reverse curve. Since the common tangent is just the sum of the two tangents of the reverse curve. So, sabi naman 1/4 ng BC is 1/4 of 122.4. So, 122.4, 1/4 niya ay 30.6. So, therefore, the tangent 1 is 30.6. Then, subtract mo yung 122.4 sa 30.6. We will have a tangent 2 of 91.8 meters. So, ganun din. Since ito na yung tangent 1 natin, ito, equal din to itong tangent. Ito dito sa tangent 1. That's why we will be able to determine also the distance from point A to PC. So, just subtract 185 by 30.6. Ito ang makukuha mong distance from point A to PC. Same din dito. Para mahanap tong distance na to, just subtract this tangent 2, which is 91.8, to 285. So, this is 193.2 meters. Okay, so ito yung computation. Since we already have the tangents for each curve, and we have the angles of intersection for each curve, we can now compute the radius for the first curve and the second curve. So using again the formula for the tangent, R tangent I over 2. So gagamitin natin yan dito sa unang curve at second curve para ma-identify yung radius niya. So since required is R, so divide both sides by tangent of I over 2. So this 14 here is 28 degrees divide 2. That's why we have 14. So 30.6 divided by tangent 14 is equals to 122.73 meters. For R2, same procedure. I2 over 2 is 60 divided 2, 30 degrees, so 91.8 over tangent 30 degrees equals to 159 meters. So, check ko. Yes. So, ito na yung unang required natin. Hanapin yung length, radius ng first curve. Ito yung sagot sa letter A. For letter B, what is the total length of road from point A to D? So, the total length of road is this. Itong dark blue, navy blue color. So, yung roadway mismo. So, from point A to PC, PC to PRC, and PRC to PC, PT, and PT to D. So, ito mang kailangan nating length. Na-identify na natin kanina. Itong length na to, ito ring distance na to, na-identify na din natin, which is equivalent to 154.4. So, naman sa kabila ay 193.2 meters. So, kailangan na lang natin hanapin, class, ay itong length of arc for each curve. So, the length of curve or length of arc is pi RI over 180 degrees. So, for LC1 and LC2. So, to compute that, add na natin lahat para sa total length. We have 154.4 pi RI over 180, which is this one, 28 degrees for I, and R1 is 122.73. For the length of curve of the second curve, ito yung radius 2. Ito naman yung I2, 60 degrees over 180 plus 193.2 meters. That's why when we add all that, we will have a total length of curve or length of the roadway from point A to point D, which is 574.08 meters. So, ganun lang. How about letter C? The question in letter C is, what is the cost of the concrete pavement from point A to D? So, given that we have a unit cost, which is per square meter basis, okay, just 1,800 pesos. It means that we can compute the cost of this roadway by determining the area of the roadway. So given that we have a width per lane of 3.05. So, 2 lanes siya. So, magkabilaan, a total of 6.1 for the width of the road. So, ganun lang class. We have to identify uh, this area. Okay? Itong area na to ng roadway. Okay. So, base sa given, kasi, per square meter yung atin. So, magagamit lang natin dito is yung width ng pavement, and given na 2 lanes, we have a total of 6.1 width. The thickness of pavement is hindi magagamit. Will not be used because if the basis for determining the cost is per cubic meter, tsaka ngayon papasok itong thickness of pavement. So, kung per cubic meter yung yung cost, unit cost ng ating pavement, tsaka natin i-multiply yung thickness ng pavement. But since per square meter lang siya, area lang ang required. So, area lang ng roadway. So, going back here, we need to determine the area from point A to point D. And madi-divide natin to into several parts. It's from point A to PC, madali lang mahanap yung area nun since it is rectangle. But pagdating dito sa first curve, so medyo curve yung ating roadway. Kaya we have to base our solution in determining the area of the sector. So, in order for us to determine this area, so magsusubtract tayo ng mga area ng sectors. Same din dito. Iba ang solution natin dyan, pero dito madali lang sa rectangle, just length times width. Okay. So, for the area of the roadway, ito, length times width lang. Pero pagdating dito sa first curve, so may dalawa tayong sector na ma-form. Yung unang sector, which has a radius which is equivalent to the radius of the first curve plus additional one lane, which is 3.05. So, ang radius kasi natin dito class ay 122.73. So, syempre, sa pagde-design, yung initial natin, path ng road ay nandun sa center line ng roadway. So, para ma-take into consider na yung width ng roadway, so we have to add the width of the roadway to the right and to the left. So, magdadagdag tayo dito. So, ang equivalent na niyan ay 122.75 plus 3.05 is 125.8. So, yan yung unang sector na ma-form natin. At ito naman yung pangalawang sector, yung smaller. So, we subtract 122.75 by 3.05. So, dyan na ngayon, labas ito, 119.68. Ito na yun. From this point to this edge of this roadway. So, kapag sinubtract natin itong dalawa, edi ang matitira na lang itong shaded area na to ng ating roadway. Same applies here sa second curve. Just subtract 3.05 para makuha mo itong distance na to. Kaya meron tayong 155.95. Then just add 2 lanes para makuha mo naman yung total distance from the center of the curve hanggang dun sa other side ng road. So, kaya ang solution natin, ganito. 154.6.1, ito yan. First part. Second part is this. Okay. So, just subtract. So, di ba, ang solution natin sa area of a sector is pi r squared theta over 360 degrees. So, yung theta natin yung I. So, pi r squared I over 360. So, syempre, dalawa yung sector natin. So, yung una, yung 1.9 119.68 plus yung dalawang lane, which is 6.1, which is ito na yun, 125.8. This is 125.8. Ito, pag in-add, then subtract 119.68, ito naman yun, yung smaller sector. Then I 28 degrees, 360 degrees. Same din dito sa pangalawang curve, 155.95, ito yan, 155.95 plus 2 lanes, 6.1 squared, minus 155.95. So, subtract lang din ito. Then, times 60 degrees over 360 degrees. Then, add the area of this rectangle, 193.2 times 6.1. So, multiply na natin, 154.4 times 6.1 is 941.84 plus, compute natin itong unang curve area, 365.86. Yung pangalawa naman, 1,015.68. So, class, may correction dun sa module. So, I will just update that later. So, mag-send ako ng panibagong copy dahil may correction dito sa part na to. So, 193.2 times 6.1 is 1178. 1178.52. So, add na natin yung tatlo. Area is 3501.9. So, class, pa-check naman kung ganito din yung na-compute nyo. So, pa-compute din, class. Ito din ba yung area na na-compute nyo? So, pa-verify. Okay, ganun din. Let's continue. Since we already have the area, we can compute the cost of the pavement. So the cost is just unit cost times yung kung ano yung quantity. Okay. So unit cost is 1,800 pesos per square meter. Multiply the area, 3501.9 square meter. The cost is 6,303,420 meters. So yun. So for a 500 meter road, inabot ng 6 million yung cost. Okay? Next. May tanong? Wala naman. Okay. So let's continue. Here, on the next problem, reverse curve pa rin tayo. Yan. Common tangent of a reverse curve is 280.5 meters and has a bearing of 47 degrees for 31 minutes south going east. AB is a tangent of the first curve whose bearing is north 72 degrees 45 minutes east. CD is the tangent of the second curve whose bearing is 38 degrees and 13 minutes east. A is at the PC while D is at the PT. The radius of the first curve is 180 meters, and the point of intersection of the first curve is at a station of 12 plus 523.37. Find the stationing of PT. So dito, magdodrawing tayo, class. Drawing muna natin tong tangents nung reverse curve. So given yung common tangent BC, which is 280.5 with a bearing of 47 degrees. So let's say, ito na lang, yung reference direction natin. Tapos drawing tayo ng line. 47 going east. So ito yung south. Ito yung east. So ito yung, sabihin natin, yan. Sige, lakihin pa natin. 47 degrees. Okay, let's label 47 degrees, 31 minutes. Ay, mali. South. 47 degrees, 13 minutes. This is point B to point C. AB is the tangent of the first curve, whose bearing is north 72.45. So, from point A going to B, ito yung bearing niya. 72 degrees, 45 minutes. So, let's say, ito naman yung second tangent. Ay, ito yung tangent, itong una. Ng curve, sabihin na natin ito. Ito yung 72. Yan. So, yan. North, galing north. 72 degrees and 45 minutes. So, wala to yung class dun sa module nyo. So, idadagdag ko na lang to. Yun. CD is tangent of the second curve. Okay. So, CD naman, north 38, 13. So, dito, okay, color blue, yan. North going east, 38. Hindi na natin pa ganyan, ang 30. Ayan. Okay. So, sa paggagawa ng common tangent, estimate nyo na lang kung kapag inad mo itong dalawa, dapat halos the same ng length nitong common tangent mo. Kasi ito yung common tangent natin. Diba? Tapos, sinabi dun kasi sa problem that point A is at PC. So, this is at PC. So, it means from PC to B, which is the point of intersection of the first, yun na yung length of tangent natin. Length of tangent of the first curve. Kasi sinabi na yun din yung location ng PC. Same applies here sa point C to D. Sinabi din doon na ito yung PT. Ito na din yung length ng tangent 2. So, yun. Then, ang gagawin nyo lang class, mag-drawing lang kayo ng perpendicular line dun sa mga tangents natin at saka natin i-draw yung radius. So, mag-assume muna tayo ng haba niya. Assumption lang natin to. Sabihin natin ito yung length nun. At dun naman sa pangalawa ay ito. So, 90 degrees. Let's say ito. Okay, ito yung radius ng pangalawa. So, paka-plot nyo nung radius nila, connect. So, kung ito sisilbing centers nung kada curve, so i-connect mo lang yung dalawa and meron ka ng tangents at radius. So, ito yung radius 1, radius 2, radius 1, sorry, radius 2. So, itong drawing na to, hindi pa to yung final kasi pwedeng makuha natin na radius ng pangalawa mas mahaba kaysa dito sa unang curve. But ito na muna yung initial drawing natin para dito. So, yun. After that, draw the curve. So, ito yung curve natin. So, from PC going to PRC, ito naman going to PT. So, kung saan yung opening nung ano, dapat nandun din yung direction nung kung saan yung opening ng mga tangents, nandun din nakapaloob yung ating curve. So, this is the PRC here, saan nag-meet yung dalawang curve. So, ganun mag-drawing class. Given the stationing at PI1, 12 plus 523.37. Okay. So, required yung radius, yung stationing ng PT. Base sa given, we have the common tangent of 280.5. So, ibig sabihin, itong distance na to from point B to point C, common tangent of 280.5 meters. Okay. So, yun. Since given na class yung mga azimuth or mga bearing nung nung mga bearing ng mga tangents, kaya na nating hanapin na yung kanyang angles of intersection sa kada curve. So ito natabunan, yung BC 4731. This is 47 degrees 31 minutes. 31 or 13. 47 31. Yung so this is 31 degrees. Okay. So yung labelan din natin yung north 38 degrees 13. North 38 degrees 13. Ito yan. 38 degrees 13 minutes from C to D. So gamit kasi yung mga bearing, kaya na nating hanapin yung kanyang angles of intersection. Kung i-extend natin to, we should determine this, I1. So kung i-extend natin yan, yung bearing ng previous curve, ay yung nung previous, tangent 1, ay magagamit natin because they are similar here. Parallel siya dito. Kaya this is 72 degrees 45 minutes. So, yun. So, kung may angle ka dito, when we add the three angles, it will have a total of 180 degrees. So, para mahanap yung angle of intersection of the first curve, just subtract those angles sa 180 degrees. Para yung matira, yun yung I1. Minus 47 degrees, 31 minutes. So this is I1, 180, 72, 45, 47, 31. So I1 is 59 and 44 minutes. Yun. Next one is this angle of intersection. Class, pwede pa ganyan, pwede na yung pa ganyan. So, ito na lang. This is C. Okay, so this is the angle of intersection, I2. So, para mahanap to, ang pwede natin gamitin class ay yung bearing nung line VC. So, kung ito, yung angle dito, which is 47, 31 minutes. So, pag kukunin natin siya dito sa sunod na point, so, ang opposite angle niya ay nandito. Dito yung opposite, which is equivalent din dun sa angle na yun. Nung bearing natin na 47 degrees, 31 minutes. Now, we add the three angles, equivalent sa 180 degrees. So, for I2, 180 degrees minus 47 degrees, 31 minutes, minus 38 degrees and 13 minutes. So, the angle here is 94 degrees and 16 minutes. Okay. So, verify nyo class baka may na-mistype, na mali akong type dito sa calculate. So, I think tama naman. 47 degrees, 31, and 38, 13. Okay. So, 94 degrees, 16 minutes. Okay, so let's rewrite that here. Rewrite na natin dito yung mga nakuha nating values so that kaya natin siyang isolve. So yung base sa given, we have the common tangent of 280.5. Ano pang given dito? Radius of the first curve, 180 meters. I1, na-identify na natin, 59.44. I2, 94 degrees, 16 minutes. Okay. So, wala nang ibang given. Since given ang ating common tangent, okay. So, kasi class, kung hahanapin natin kasi yung stationing ng PT, given the stationing of PI, kailangan muna nating pabalikin yung stationing na papunta sa PC. So, the stationing of PI1, kailangan pa nating isubtract yung T1, then add the LC1 or the length of the first curve and the length of the second curve. So, ganun lang class. So, T1, kaya na nating identify, but the length of the first curve, kaya na din, but the second curve, hindi pa natin kaya since wala pa tayong radius of the second curve. So, hanapin muna natin yung radius of the second curve from the common tangent. The common tangent is just the sum of the two tangents. So, tangent 1, R1, tangent I1 over 2. So, R1 is 180 meters. Tangent I1, 59 degrees, 44 minutes divided by 2. So, T1 is 103.365 meters per ton. So, tangent 2 can determine that by substituting here to 80.5 meters. Tangent 1 is 103.365 meters plus T2. So, therefore, T2 is 280.5 minus 103.365 equals to T2. So, the tangent 2 is 177.135 meters. Okay? So, kung meron na tayong tangent 2, apply again the formula for tangent to identify, to determine the radius of the second curve. So, divide both sides by tangent I2 over 2. We will have T2 over tan I2 over 2, which is equals to R. Now, substitute T2, 177.135 over tangent of I2 is 94 degrees and 16 minutes divided by 2. So that's the radius of the second curve. So the radius of the second curve is tangent 94 degrees 16 minutes over 2. Okay, 164.412 meters. So double check natin. Over 94. Okay, correct. So this is the radius number 2. T1 meron na, LC1 and LC2 pwede na natin i-determine. So dito ko na lang i-continue. LC1 formula pi R1 I1 over 180 degrees. So R1 is 180 and I1 is ano nga yun? 59.44. 59 degrees and 44 minutes divided by 180 degrees. LC1 is 187.658. LC2 pi R2 I2 over 180. R2 is 164.412. I2 is 94 degrees and 16 minutes. Oops. Nag-black screen. Okay. Class, nakikita sa screen nyo pa rin yung solution? Verify ko lang.
Yes, sir.
Yes po, sir.
Okay. So, thank you. 94 degrees, 16 minutes. 180 degrees. Okay. LC2. So, 164.412, 94, 16,
270.5.
180. Okay, 270 point what? 0.5? 01?
0.5 po.
Okay. Okay. Next, pwede nang i-compute yung stationing ng PT. So, rewrite ko lang. PI1 minus T1 plus LC1 LC2. Okay. Stationing 12 plus 5 to 3.37 minus T1 103.365. I-add natin yung LC1 187.658 and LC2 270.501. So, stationing ng PTI. So, add natin. 12 plus 5 to 3.37. So, that's 12,523.37 minus 103.365, 187.658, 270.501. So, stationing natin sa PTI 12 plus 878. 878.164 meters. So, ganun lang. So, ganun lang sa non-parallel tangents. Usually, binibigay yung bearing ng mga tangents. Okay? And yung mga bearing na yun ay makakatulong din sa paghanap ng angles of intersection of each curve. Okay. So, tapos na tayo sa reverse curve. Any question sa reverse curve? Wala naman. Okay, next. Okay, dito na tayo sa last part ng ating lecture, which is about spiral curve. So, this is spiral curve. So, spiral curve or roadway with a spiral curve, this is the final form of a design of a road. So, sa pagde-design kasi ng length ng spiral curve, maraming kino-consider. Isa na doon yung design speed ng road, syempre yung radius ng curve, and pwede pa ditong kino-consider yung friction, okay, friction of the road, and yung super elevation. So, lahat ng yan, may encounter nyo yan class sa transportation engineering. So, dito sa discussion natin sa spiral curve, we will just focus more on the formulas that are used in computing the parts of or in determining the parts of a spiral curve. So, as you can see, ang spiral curve dito class ay ito. From this point to this point. Ito lang ang spiral curve. So, ang mga parts ng spiral curve as a whole, ng roadway na may curve as a whole, is that we have a spiral curve. Spiral curve is also called as the transition curve. Sa transition curve kasi, di pwede na from a straight road ay bibigla tayong liliko o i-introduce agad yung simple curve natin. So, uh, medyo hindi yun safe because there will be sudden change in direction. So, kailangan dapat may belo tayo sa liko. So, dapat merong transition to reach the maximum degree of curve natin. So, yung transition na yun na yung ating spiral curve. So, from a straight road, paunti na paunti hanggang ma-reach niya, naliliko, hanggang ma-reach niya yung direction na kung saan uh, yun na yung pinaka-maximum na degree ng curve na dun yung ating simple curve. So, ang simple curve kasi, ito yan, itong nasa gitna, ito na yung simple curve na kinocompute natin nung previous lesson. So, dito kasi located yung pinaka-maximum na degree ng curve natin, o yung maximum na liko. At sa pagdi-design din ng road, dito din na sa simple curve, na-attain yung maximum super elevation. Okay, so syempre kung mahalata nyo yan kung nakasakay ka sa kotse, kung liliko, so makikita nyo na ang roadway natin ay naka-slope. Okay, depende sa kung anong direction ng curve. So ang purpose kasi niyan ng super elevation o nung slope nun sa roadway is to counteract the effect of centrifugal force. Okay? Kasi kung liliko ka, so di ba sa rotation of a certain object ay may tinatawag tayo na centrifugal force where it is a force that is acting uh, outward from the center of rotation. So go palayo dun sa center nung direction nung isang rotation. Meron tayong centrifugal force. So ang force na yun palabas galing dun sa center ng circle. So ganun din sa curve. So kung liliko yung kotse, there is a tendency that ang force na meron dun sa sasakyan natin ay ma-push siya papunta sa labas ng roadway or tumilapon siya ganyang direction, okay? So kung hindi tayo mag-introduce ng super elevation, so at pwedeng mag-overturn yung ating sasakyan. So yun yung purpose ng pagdi-design ng super elevation ng road. So isa din yun sa purpose ng spiral curve is magkaroon din ng transition from having a flat surface. So actually hindi yan flat surface din ang road natin. May slope din yan. Pero sa transition curve from the straight road which has a flat surface, meron din siyang transition in having the maximum super elevation or slope ng curve. Yeah. So, magkakaroon ng transition din. So, kaya kung mahalata nyo, dun sa parang midsection ng ating roadway na may horizontal curve, nandun yung pinaka mataas na slope. So, hindi naman natin yan in class pag-aaralan ngayon yung super elevation kasi sa transportation engineering na siya. But yun nga, ang purpose nga ng spiral curve o transition curve is magkaroon nga ng transition to attain the maximum degree of curve which is located dito sa simple curve natin. And as well as to have a transition also on the super elevation ng curve when having a when having a turn. So, yun nga. So, ito lang ang ating spiral curve. So, ito ang parts niya. We have TS or tangent to spiral. Kasi meron din tayong tangent sa spiral curve. So, if we're going to extend that tangent there, okay, hanggang dun yan. Then, from tangent to spiral, we will have spiral to curve o yung simple curve na natin. Then, going to curve to spiral or CS. Curve going to spiral. and spiral to tangent or ST. So may tangent din dito sa ST. So kung i-extend natin yan, makaka-form ulit tayo ng angle of intersection. Angle of intersection I. Okay? So, yan. So mag-focus tayo dito. For that, meron pa pala tayong tinatawag na external distance. So, yun nga, pag mag-plot tayo magli-layout na tayo nung horizontal curve natin, essential din ang external distance. So, syempre, radius ng curve R. And may tinatawag din tayong length of throw. So, ang length of throw, parang siya yung parang offset din nung initial location natin nung roadway or nandito sa kabila, same din dito, going to the point na kung saan yung direction ng ating curve. So, yun din yung length of throw, which is P. So, let's focus here on the transition curve or the spiral curve. So, ito na ang spiral curve. May tinatawag tayong length of spiral or LS. Siya yung distance from TS to SC. So, or yung full length ng spiral. So, at any point, kaya may pinapahanap tayo at any point, ang tawag naman doon ay length of the spiral at any point. So, dito as a whole, length of spiral, meron din siyang equivalent offset distance. Okay, the offset distance is measured from the tangent perpendicular to the tangent to the point ng SC. Now, this is XC, or the offset distance from TS to SC, or from tangent to SC. And meron din tayong YC, or the distance along the tangent. Okay? From TS to SC. And kung at any point naman yung pinapahanap, so meron din tayong equivalent offset distance and distance along the tangent. So we just assign X and Y. Pero kung hanggang SC, just lagyan nyo lang ng C. Okay? XC and YC. Next, we have here the theta S or yung spiral angle. So, the spiral angle, so para siyang yung tangent din. Tangent dito sa point ng SC, and if we are going to extend that here, kung ano yung angle na form natin from this tangent ng ating spiral, that will be your spiral angle. But if at any point, pinapahanap yung spiral angle, so kunyari dito sa point na to, so extend mo lang yung tangent line galing sa point na yan and measure it from the tangent of the spiral curve. And yung theta na yun ay yung ating spiral angle at any point. May tinatawag din tayong I, or the deflection angle for TS to any point of the spiral. So, ang deflection angle, so kung maggagawa tayo ng line from TS to SC, the angle formed from the tangent to that line is called the deflection angle. If hanggang SC, so TS to SC. Kung at any point naman, yung angle naman ulit na ma-form by measuring the angle formed by a line connecting that point to TS, yun naman yung deflection angle natin at any point, from TS to any point. Okay. So here are the formulas used for spiral curve. Yan. So for the distance along the tangent at any point, we have L minus L raised to 5 over 40 R squared LS squared. Now, kung pinapahanap naman ay yung YC, just replace L by LS here. And tsaka natin madiderive itong equation na to, which is LS minus LS cubed over 40 squared. For the offset distance at any point, we have L cubed over 6RLS And kung XC naman yung pinapahanap, just substitute again L by LS para cancel out. Ang magiging equation naman para sa XC ay LS squared over 6R. For the length of throw is 1/4 of XC. So just compute the 1/4 of XC. Ito na ang kalalabasan, LS squared over 24R. So R is the radius of the simple curve. Next, spiral angle from tangent to any point on the spiral. Theta. L squared over 2R LS. So kung pinapahanap naman theta S, replace mo ulit L by LS. Ito na yung kakalabasan. So much better if ang i-memorize nyo na lang ay yung distance along tangent at any point. So offset distance, para kung pinapahanap naman is from TS to SC, just replace or just substitute L by LS in order to determine the YC and XC. Ganun din sa theta S and sa IS. I think this is IS. Okay? So, yun. So, for IS, 1/3 lang siya ng ating spiral angle. Ang ating deflection angle, 1/3 lang ng spiral angle. So, ito naman yung equivalent formula. L squared over 6 RLS. So, ganun lang, class. Medyo madami ang formula sa spiral curve. So, the distance, tangent distance, okay. Itong formula, LS over 2 plus R plus B, tangent I over 2. So, itong mga formula na ito, na-derive lang naman to dito sa spiral curve, in which dito, if we have the simple curve here, gagawa ulit tayo ng additional curve with the same radius basing on the spiral angle. So, meron tayo dito sa isa and dito sa kabila. Ngayon, yung distance measured from that point to the tangent, yun yung ating length of throw. Okay, yung edge ng point kung saan gumawa tayo ng another curve using the spiral angle. Yun yung length of throw. And yung distance na yun, galing sa ST, is almost similar or in length with the length of spiral. Okay? That's why from that, maano natin, makukompute natin, o madiderive natin ng TS. Ito yung TS. Okay? So yung TS, when we subtract LS, maging TS minus LS. Then, tsaka tayo magpo-form ng right triangle dito. Itong right triangle na to. Then, just apply trigonometric function. Cosine or tangent. Then, tsaka na ma-derive itong formula na to. So, natin i-derive. Ito na yun. LS over 2 plus R plus B tangent I over 2. So, ito, R plus B. So, yun. The angle of intersection of simple curve is IC equals to I minus theta S. Ang IC natin, class, is the angle of intersection of the simple curve. So, huwag mapagbaliktad na iba ang angle of intersection ng buong curve, ng length of ng spiral curve, to the angle of intersection ng simple curve. So, to determine the angle of intersection of the simple curve, I minus 2 theta S. O yung theta S ay yung ating spiral angle. External distance, ES, ito. So, R plus B over cosine I over 2 minus R. So, I think this is LS over 2 pala. LS over 2 to. Itong distance na to. So, this is LS over 2. Okay? So, dun lang na-derive. Okay. So, yun, class, madami ang formula ng spiral curve, but it is recommended that you should memorize all those formula because all those formula are essential. So, kami, during the board exam, this spiral curve, madami siyang beses na lumabas sa board exam ko. So, it's a shame if you don't memorize this formula because uh, isa din to sa favorite na kunin na problem sa board exam, the spiral curve. So, yun. Memorize nyo yan, class. Though, kung face-to-face talaga tayo, papamemorize ko talaga to sa inyo. Okay, so, sa ngayon, just be familiar with the formula. Okay? Sige, example na tayo. May katanungan, class. May katanungan sa discussion o sa mga formula ng spiral curve.
Wala po.
Okay, wala. Sige, mag-proceed na tayo. So, ang kagandahan lang sa mga problems na ma-encounter natin sa spiral curve is that, ano siya, formula-based lang. Formula-based yung mga problem natin dito. Kaya, kailangan lang kabisado yung formula para ma-solve natin siya. Okay? First problem, spiral having a length of 80 meters has a central curve with a radius of 280 meters. Determine the offset distance from the tangent to the first quarter point of the spiral. So the given are length of spiral 80 meters, central curve, radius 280 meters. Hanapin daw yung offset distance from tangent to the first curve. So at any point siya kasi minention dito yung location ng pinapahanap na offset distance which is at the first quarter point. So ang first quarter point natin, which is L, is located at 1/4 of the total length of the spiral. So 1/4 of LS is, or 1/4 of 80 is 20. That's 20 meters. So yun. So gusto pa nating tingnan yung figure, gawa ng figure. Ito yung tangent mo at ito din yung spiral curve. Yan yung spiral curve. Yan. So this is LS. LS, 80 meters. Yung first quarter point natin, let's say nandito. 20 meters. Pinapahanap, offset distance is right here. Perpendicular distance from the tangent. Okay? So the formula is x equals to L cubed over 6R LS. So substitute lang, class. 20 cubed over 6R, 280. LS is 80. So x therefore is 0.06 meters. So ganun lang. Next. The length of throw of a spiral is 1.42. Okay. Length of throw P, 1.42 meters. What is the corresponding offset distance at the SC? So, ano ba yung offset distance natin? What is XC? So again, XC, ang length of throw, class, is 1/4 of XC. So, kung ito yung required, multiply both sides by 4. So, 4P equals to XC. 4 times 1.42 equals to XC. Or, XC is equals to 5.68 meters. So, yan. Yun na yung sagot para sa offset distance at SC. Next. What is the appropriate radius of the central curve if an 80-meter spiral Smith curve has a distance along the tangent of 59.46 meters. So given, okay. So actually, kahit hindi ka na mag-drawing class, i, ano mo lang, ilatag mo lang lahat ng given and use the formula. Use all the formula. Kaya na natin siyang isolve. Okay? So, sa transportation engineering, ibang usapan na yun. Kasi maghahanap tayo ng stationing ng lahat. So dito, formula na lang tayo. Hanapin lang natin yung mga parts ng spiral curve. So given dito lahat ng spiral ay 80 meters. Smith curve has a distance along tangent of 59.4. Tama ba? Ay, hindi. Sorry. Distance along tangent is y. Okay? Y is 59.46 at third quarter point. So pag sinabi natin third quarter point, that's located 3/4 along the length of spiral. So ang L pala natin ay 3/4 of LS. 3/4 of 80 is 60 meters. Pinapahanap dito ay hanapin yung radius of the central curve. Okay. What is the radius of the sides of the simple curve? So given yung y, so let's use the formula L minus L raised to 5 over 40 r squared L squared LS squared. Substitute natin 59.46 equals to 60 minus 60 raised to 5 over 40 times r squared L 80 squared. So, repeat natin 59.46 minus 60 is equals to negative. Evaluate na natin 60 raised to 5 over 40 times 80 squared. So, compute natin yan. Ang kalalabasan ay 6,075 over 2r squared. Okay, subtract natin itong dalawa. That's negative 0.54. So, ito na siya. Okay, so cross-multiply natin yung r squared dito sa denominator. Multiply natin both sides by r squared over negative 0.54. Okay, para r lang matira. Separate natin yung r. So, r squared equals to cancel. 6075 over 2 times 0.54. Okay, positive 5625. R squared. Ay, sorry. Ano pala? Cancel out na yung r squared dito. So, take the square root of both sides. Square root of that is 75. Unit natin ay meter. Okay. So, yun lang class sa problem na to. Next. Spiral curve has an external distance of 16.6 meters and the length of throw of 1.6 meters. Determine the radius of the central curve if the angle of intersection of the spiral tangent is 42 degrees. So given yung angle of intersection of the spiral tangent. So yan ay yung I. Okay? Other given, we have the external distance is 16.6. Length of throw P, 1.6 meters. Hanapin daw yung kanyang radius. Okay. So from the formula of external distance of R plus P, secant I over 2 minus R. We have here 16.6 equals to R plus 1.6 second second of 21 degrees, which is half of 42 degrees, minus R. So 16.6 is equals to second of 21 is 1 over cosine of 21, 1.07. So 1.07, multiply natin dito, 1.07 R times 1.6, 1.71 na siya. Then ito, minus R. Okay. So combine like terms. So transpose natin yung 1.71. Then 1.07 R minus R is 0.071 R. Okay. 16.6 minus 1.71, 14.89 equals to 0.071 R. Divide both sides para mahanap si R. Okay. That's 209.72 meters. Okay? Formula based lang. Last example. An 80-meter spiral curve connects the central curve of radius 200 meters. Determine the spiral angle at SC. So given R, LS, 80 meters. The radius is 200 meters. Hanapin daw yung spiral angle, which is theta S. Formula, theta S is LS over 2R. So 80 meters over 2 times 200 meters. So class, ang kalalabasan lagi sa formula na ginamit natin para sa theta S ay lagi naka-radian. So we have to convert that to degrees. So kung i-convert natin siya, kasi kung minsan nagagamit yung theta, yung spiral angle sa ibang computation ng any part of the curve, which is hindi dapat naka-radian ang gagamitin natin. Lalo na gagamitan ng trigonometric function na sine, cosine, or dun sa mga previous, yung mga ibang formula. So you have to convert this to degree. So 180 over pi, yan ang conversion factor natin to convert that from radian to degree. So, compute na natin, ang kalalabasan ay 11.46 degrees. This is the spiral angle at SC. Okay. So, yun na class. That ends our lecture in horizontal curves. So, may katanungan ba? Any questions?